In this lesson, our goal is to take all of our ideas that we've been doing about derivatives, where the basic idea, the concept behind a derivative is understanding how to find a slope of an equation, especially it's an equation that we're not used to seeing, like something that's nonlinear, non-quad, or something like quadratic or cubic. So, anytime we're taking a derivative, it's helping us find the slope at specific points along those curves. And we're going to connect this idea, the whole idea of derivatives, with our trigonometric functions. So the 6 main trigonometric functions are sine, cosine, and tangent. Then, of course, cosecant, secant, and cotangent. Okay. So what I've drawn here, first of all, to get started, is there are the four our two main graphs I want you guys to look at for just a second, followed by two more. And if we look at the graph of y equals sine x, okay, and let's really analyze this to help us figure out how we're going to get the derivative of it. Okay. If I look from 0 to pi over 2, if I focus on that interval right there, because my graph is increasing, that means that my slope should be positive. Okay, now I'm going to put that as pi over 2. And now to get from pi over 2 down to 3 pi over 2, this whole interval right here, since my graph is going down, that means my slope should be negative. Okay, so from 0 to pi over 2, my slope is positive, and from pi over 2 to 3 pi over 2, my slope is negative. So what I want to do is look at one of these other four graphs right here. Do you recognize any of a graph that would represent from 0 to pi over 2 that I'm above? In other words, when it's positive, what that means is I'm above the x-axis. So anytime my graph is increasing, my slope is a positive, it means I need to be above x-axis. And anytime my graph is decreasing, therefore my slope should be negative, that represents that I should be graphing something that's I'm sorry, I'm saying above, but it should be below the x-axis. Okay? Well, if I look at these graphs, from 0 to pi over 2 right here, I'm below, and it should be above. So definitely it's not this part B. If I look at graph number C, from 0 to pi over 2, I'm above, and from pi over 2 around to 3 pi over 2, I'm below. So as you're seeing right here, is it looks like the derivative of the sine graph, which is graph A, is actually going to be this graph down here, graph C, which is the cosine graph. Okay, so let's look at this again just one more time. From 0 to pi over 2, my graph is increasing, so my slope should be positive, which is representative by above the x-axis. From pi over 2 to 3 pi over 2, my graph is decreasing, so my slope is negative and should be drawn below the x-axis. From 3 pi over 2 all the way up past 2 pi to the next, it's always increasing, and look, it's always going to be above the x-axis. So there you go. There's the first way on how, if you want to look at it, on how to find the derivative of the sine graph. Well, the derivative of the sine graph, this is what I'll have written down below, but the derivative of sine is then just regular cosine. Okay, well, let's start with the cosine graph and see if we can get the derivative from there. Okay, on the derivative of the cosine graph, let's analyze it. It's saying from 0 all the way down to pi. So from 0 to pi, I'm decreasing. So I need to see a graph that represents being below the x-axis from 0 to pi. And then from pi to 2 pi, I'm increasing. So I should be positive for my slope, which means above the x-axis. So what graph will go from 0 to pi all below, and from pi to 2 pi all above the x-axis? Okay. Well, here's 0 to pi all below the x-axis, and from pi to 2 pi all above the x-axis. So it's looking like that one's going to work, but let's check this other one. This one down here on the bottom right only has 0 to pi over 2 below, so that's definitely not going to work. So what we just found out here is then that the derivative of the cosine graph is actually the negative sine graph. Okay, and there's two of our formulas that we need for this lesson above. And as I kind of scroll down and y'all look at your notes too, that's basically what I've just been saying in this first part. It's just developing the connection that really the graph of the cosine graph is represented as the graph of the derivative for sine. So the derivative of sine is cosine, and then looking down here, then the negative or the reciprocal of the, when you take the sine graph and you reflect it over the x-axis, what that represents is the derivative for the cosine function. Okay, now to get the other functions like tangent and cotangent and secant and cosecant, all I did was just write them in terms, it's like if you want to just memorize sine and cosine, this is the way to get the rest of them if you want to quickly do it that way. Okay, and I wrote tangent as just being sine over cosine, and so therefore if I want to take the derivative of this thing right here, we use our quotient rule. Okay, so the derivative of tangent is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Well, I just replace the derivative of a sine with what we just found it to be, which is cosine, and the derivative of cosine, which is negative sine x, which we just found. And then just finishing cleaning this up and realizing that we have an identity right there, that cosine squared plus sine squared is 1. So all that gets replaced with 1, and we have just developed the derivative of tangent as being secant squared x. Okay, and in order to get cotangent, just do the same thing. Instead of looking as tangent as sine over cosine, go cotangent as cosine over sine. Do the quotient rule on it, and you'll get the exact same thing. So the derivative of the cotangent is the negative cosecant squared. All right, and I kind of followed the exact same thing in a way with when I was finding the derivative of secant. I wrote it as 1 over cosine right here, and then I did the chain rule, or I did the quotient rule. So bottom times the derivative of the top minus top times the derivative of the bottom over bottom squared. Well, the derivative of 1 is 0, so it makes that whole front term just go to 0. And the derivative of cosine is coming down here is be our negative sine x. So all that over cosine squared. And then when you kind of just pair it up, you want to treat it as like times 1. So sine over cosine is tangent, 1 over cosine secant, and therefore you found your rule right there. So the derivative of secant is secant x tangent x. And doing the similar process. Y'all, if nothing else, y'all pause the video, kind of go back through this a little bit more slowly. You've got time to look at this. You can kind of follow my steps on how I did this. But the derivative of cosecant is done the exact same way. Write it as 1 over sine, do the quotient rule, and then you'll get right back here to a negative cosecant x cotangent x. Okay, so that's pretty much the foundations of this lesson, and from here we're just going to do a bunch of examples. So let's go on to example 1.